Hi students, welcome to this video session. My name is Samuel Chukwu Emeka, as usual. In this video session, we shall solve examples on simple interest problems, compound interest problems, and continuous compound interest problems. Please, before you view this video, it is highly recommended that you know the theory. We've done the theories in the videos on interest and annuity. If you go to my website, you will find the videos we did on a simple interest, compound interest, continuous compound interest, and the annual percentage yield, APY. So we shall solve problems on this. It is recommended that you know the theory before you view these. Now, let's recall the formulas we have that we may use to solve these problems. This is a series, this is like just problem solving. That is what we are doing, and we shall have more videos on problem solving questions pertaining to these interests and annuities. So let's start with a simple interest. Simple interest. Let's call this SI. Okay. Let's kind of write all the formulas that we might need. We might the first formula we probably need is that the simple interest is principal times rate times time. Later on, let us write out all these formulas. Then later on, we will write what they mean. The second one, we have that the amount is the principal plus simple interest. Okay. Now let's go to compound interest. Compound interest. Let's call this CI. Please do not confuse it with a confidence interval. Okay. I am just calling it CI. Number one, we have A will be equal to P times 1 plus R over M exponent MT, M times T. Number two, some textbooks you will find these formulas. A is equal to P 1 plus I exponent N. The third formula we shall list here is that I is equal to R over M. Then the fourth formula we have here is that N is equal to MT, M times T. The fifth formula we shall list here is that CI, compound interest, is equal to A minus P. And like I said, I'm going to write out what all these means. Okay, we shall write out what every one of them means. Okay, then let's write the continuous compound interest. Continuous compound interest. We have written all these formulas before in the previous videos, so it is recommended that you view those videos. Continuous compound interest, let's call it a CCI. Okay, the first one we'll write here is that A is equal to P RT then the second one we'll write here is that continuous compound interest is equal to A minus P. Okay. Now let's write the one for annual percentage yield, and then we shall write what all these means. Okay, we shall write what all of them means. Annual percentage yield, or some textbooks will write it as effective interest rate. Effective interest rate, or some textbooks will write it as a true interest rate. True interest rate. So the formulas we have here, we have basically two formulas for, well, we have basically three formulas here. We have number one, APY is equal to 1 plus R over M exponent M minus 1. Okay. Number two, we have that APY is equal to 1 plus I exponent M minus 1. So these two formulas we just wrote is for compound interest. Compound interest. Then the third formula we have is that the APY is equal to E exponent R minus 1. And this one is for continuous compound interest. Continuous compound interest. So we have defined what all this means. Okay, so now let's write what all these let's write what all these symbols mean. So where SI, we call this simple interest. Of course, this simple interest, we have it in dollar, or it should be in any currency that your country is in. Any currency at all. In America, the legal tender is dollars. Okay, in Nigeria, the legal tender is naira. We have that CI is the compound interest. In dollars, it's gonna be in dollars too. We always put the unit, always. CCI, we have it as a continuous compound interest. Continuous compound interest in dollars. APY, we have it as annual percentage yield. Annual percentage yield, and this is in percent. Okay, this is a rate. It's an interest rate, so it's in percent. A, we have A as the future value. Future value or amount. If it was in simple interest, it will be simple amount. If it's compound interest, it will be compound amount. And this is in dollars. This is in dollars also. P is our present value, or principal, in dollars is in dollars, or in, like I mentioned, any currency that is any legal tender in your country. R, small r, lowercase r, is the annual interest rate. Annual interest rate. And it's in percent. Okay. M is the number of compounding periods per year. Number of compounding periods per year. These notes, I am going to post these notes on my website. Okay. These notes I'm writing now, I am kind of doing two things at the same time. I am writing the notes as I am also recording the video. So the videos will be on my website and the notes will be on my website as well. M is the number of compounding periods per year. It really does, it is unitless. Okay. T is the time, and the time is in years. Okay, our time is in years. I, lowercase I, is the annual interest rate per period. Annual interest rate per period. Per period. Per period. N, lowercase n, is the total number of compounding periods. Total number of compounding periods. Lowercase e. E is the Euler's number. Euler. Leonhard Euler's number. In some textbooks, Euler's number. Please, not Euler's constant, but Euler's number. In some textbooks, they will also say Napier's constant, or Napier's constant. E. It is in your calculator, and we talked about it in the first video, in the previous videos that we've done on this. I think that is everything that we need. Okay, I think that is everything that we need so far. Now, the next thing we will do now before we solve questions is to find the values of M. Okay, M is the number of compounding periods per year. Okay, if it is compounded annually, what is M? If it is compounded semi-annually, quarterly, monthly, weekly, okay, we've got to find what those, what we have to find the meaning, what the values of M. So we will write it here. If compounded, then what is the then value of M? Value of M. So if compounded annually, then M is 1. Okay, M is 1, which means one time per year. Okay, M is 1, which means one time per year. If compounded semi-annually, That means that M is 2, which is 2 times per year. 2 times per year. If compounded quarterly, you hear of a GDP growth, quarterly growth. Okay, that means M is 4. Quarterly means 4 times per year. 4 times per year. If compounded monthly, every month, monthly, that means M is 12. 12 times per year. If compounded weekly, every week. How many weeks do you have in a year? Usually we say 52. This means how many do you have in a year? Okay, you have 52 times per year. 52 times per year. So 52 weeks in a year, 12 months in a year, 4 quarters in a year. Okay. Then if you compounded daily, how many days do you have in a year? Let's say 365, assuming. Okay, so this is 365 times per year. Okay, so we have talked about the formulas and then we have talked about the value of M. Now, let us start solving some questions. I have written the questions already to save time, so we shall just read them and explain them and start solving, Okay, so the first question, 5.5 years ago, Peter invested $20,000 in a retirement fund that grew at the rate of 12.45% per year, compounded quarterly. Okay, so I'm going to use this pen and circle what we need and just write what we need. This is compounded quarterly, so this is compound interest. Okay, now when you read questions, you want to find out clues of what to use. Okay, we see compounded quarterly, and he invested $20,000 in a retirement fund that grew at the rate of 12.45 per year, compounded quarterly. How much does he have in his account today? Okay, that reminds me, in all the questions we shall do in this video, we shall round to the nearest cent or 2 decimal places. Okay, in all questions, for all questions, round to the nearest cent, or what you say, hundredths, okay, or 2 decimal places, 2 dp, 2 decimal places. So all the questions that we shall do in this video, we shall round to 2 decimal places. Okay, so now this is compound interest. Of course, they told you compounded quarterly. If it was continuous compounding, they will tell you that. And then they say, how much does he have in his account today? That means they're asking for future value. Okay, that means the present value P is 20,000, right? The interest rate R is 12.45%. Now, for interest rate, please note this. For interest rate, if they give it to you in percent, you've got to change it to decimal. Then if they ask you to find it, after finding it in percent, you have to after finding it in decimal, you have to change back to percent. Okay, let me repeat. For interest rate, if they give it to you in percent, you have to change it to decimal. Then, if you're asked to find it, okay, you find it in decimal, and then you have to convert back to percent. And of course, percent to decimal, you have to divide by 100. So this gives you a 0.1245. Okay, 0.1245. So we've changed that. Then 5.5 years ago. Okay, let me go ahead and underline this also. 5.5 years ago. So that tells you that T is 5.5. Now, if you, let me say something here. You will use a calculator anyway. For all the calculations we will do in this video, we shall use calculators. Okay, so if you have a decimal that you can easily convert to percent, that won't give you repeating decimals, you go ahead and do that. So I'm going to put this as 5.5. It's in years already, so I'm good. Okay, it's in years already. If not, I have to convert. Remember, time is in years. All those things I gave to you, the units, it must be in that. If it is not in that, you have to change it to that. You have to do that. Okay. Then compounded quarterly means that M is 4. Right? So, you know the formula that I'm going to use? A is equal to, because we are asking, they are now asked us for A. We are being asked for A. What is A? So A is equal to P times 1 plus R over M exponent MT. So A will now be equal to 20,000 times 1 plus 0.1245 over 4 raised to power 4 times 5.5. Okay, so let me deal with this guy first, the exponent part first. Let me deal with him first. 1 plus 0.1245 over 4, 4 times 5.5. So I'm going to use, use this video, I use this calculator in those videos I did. And I'm gonna use it again here, and you kind of see what I do right away. 4 times 5.5 gives us 22. So see what I do now to find the amount so that I won't waste time. I will come immediately. I will first of all do this guy. I'm gonna circle what I'll do. I'm gonna do this guy first. Okay, I'll do this guy first. After doing this guy, 0.124. You know, we are doing PEMDAS. Use PEMDAS. PEMDAS. We are gonna use PEMDAS. That's the thing. So we have parentheses first. That's the first thing we do. But inside this parentheses, we have this addition and division. Okay. So we'll do the division first, then the addition, right? Then we do the exponent. We do the parentheses first, then we do exponent, and then we do multiplication. Okay, now but inside the parentheses we have addition and division. We do the division first, then we add it, then we do this exponent, then we multiply. Okay, so that is what I'm going to do here. So see how I will do it in this calculator. 0.1245 divided by 4 gives you this. Then please do not, a very important thing to note, please listen. Do not approximate in the middle. You only approximate in the end. That is round 2 decimal places. Only in the end. Not while you're still solving. So use it. Don't come and use 0.031. You will get it wrong. Use exactly as it is. So first of all, divide equal to this. Then you do plus 1 equal to this. Then you raise to power 22 equal to this. Then you do times 20,000. Now, some of you have calculators. that if you put it immediately, it gives you, if you put it in well, it gives you the answers. Okay, those ones are good. If you have them, that's fine. Some of you have calculators like that. Well, the one I'm using now, you have to do it step by step so you don't get it wrong. So what we got here, we have $39,253 and 55 cents. That's what we got. This becomes your answer. 55 cents. That's the future amount. So what this is saying is that if Peter invested $20,000 in this retirement fund, okay, after 5.5 years, he will have a $39,253.55. Now, if they asked you what was the interest he accrued, okay, what was the compound interest that he accrued, then it will be A minus P. If you look at the formulas we wrote, it will be $39,253.55, 196. You have to use the original thing here, minus the 20,000, and that will give you the interest. Okay, that will give you the compound interest. But this is the amount that he got, that he will have after 5.5 years. If he invests 20,000 in that account, in that retirement fund. Okay, next question. Find the effective rate of interest for a nominal rate of 5% per year, compounded I annually, II semi-annually, III quarterly, IV monthly, then V continuously. So effective rate of interest. This is what we're asked to find, because you will have to know what are you asked to find. You have to know that first. What are you asked to find? Nominal rate of 5% per year, and then compounded this. Okay, so we see that the first 4 questions are compound interest. APY, effective rate of interest, is like we said initially, it is APY. Another synonym is true interest rate. So, and I gave you the formulas for both the compound interest and for the continuous compound interest. Okay, so we use the formula for the compound interest for the first 4, and then the other one for the continuous compound interest for the 5th one. Okay, so let's start. I for annually, M is what? 1, right? And of course our R is 5%, which is 5 over 100, which is 0.05. Okay, then we now have to find our APY, because that is all we need. APY will be 1 plus R over M exponent M minus 1. So this APY will be 1 plus 0.05 over 1 exponent 1 minus 1. So let's see what this one gives us. You first of all do this one, 0.05 divided by 1 gives you 0.05, then plus 1 gives you that 1.05, exponent 1 gives you 1.05 minus 1, and you have 0.05. So this is a 0.05. Now remember what I said earlier on, that if you are asked, if you're given interest rate, okay, in percent, if you have to use it, you have to change to decimal. Now, but if you're asked to find it, you find it in decimal, and you have to convert back to percent. Convert back to percent. So you multiply by 100, okay? So the APY will be 0.05 times 100, and that will give you a 5%. Now, to 2 decimal places, 5% to 2 decimal places will be 5.00%. Okay, so you take note of that. Semi-annually, M is what? 2. And the arrow is still 0.05. So the APY will be 1 plus 0.05 over 2 exponent 2 minus 1. Okay, APY will be, so you do 0.05 divided by 2 gives you this, then plus 1 equal to this, exponent raised to power 2 equal to this, minus 1 equal to this. So that will give you 0.05. This will give you 0.050625. Multiply by 100. Okay, that will give you 5.06. And change to 2 decimal places. 5.06% to 2 dp. Okay, see what we got here. 5.06% to 2 dp. Okay, that will give you this to 2 decimal places. All right, let's finish up the rest. Quarterly, monthly, continuously. The third one, quarterly. Quarterly means that M is 4, R is still 0.05. APY, let's write the formula again, will be 1 plus R over M exponent M minus 1. So APY will be 1 plus 0.05 over 4 exponent 4 minus 1. So that gives us that. We do the same thing here. 0.05 divided by 4 equal to this, plus 1 equal to this, raised to power 4 equal to this, minus 1 equal to this. So that gives us this. And if we multiply it by 100 to 2 dp, that will give us 5.09%. Okay, to 2 dp, 2 decimal places. IV, we have that our M monthly, so M is 12, our R is still 0.05. So our APY will be 1 plus 0.05 over 12 exponent 12 minus 1. So our APY will be 0.05 divided by 12. Okay, then plus 1 equal to, then exponent 12 equal to, then minus 1 equal to, times 100 equal to 5.12. 5.12%. It's a 5 point. It's actually 5.116189. You know, but if you round it up to 2 decimal places, like we said in the video, it's gonna be 5.12%. So let me circle this as the answer. Circle this as the answer. Then the last one is continuously. Continuously. Compounded continuously. So what we got here, we have that the APY, here we are not concerned with M, it's just that our R is 0.05. So APY will be the Euler's number exponent R minus 1. Okay, and I'm going to show you how we get this. This is equal to E exponent 0.05 minus 1. So our APY will be is going to be With the calculator I'm using, my e exponent x is here, so, and I have to press shift, because it's on top. Okay, all this yellow, all this color, yellow color, orange color, I have to press shift first before I use it. Shift, e exponent, raised to power 0.05, then equal to, okay, I have to do it again. First of all, let me do e 0.05 like this, okay, because it's e exponent x, then equal to this, then minus 1, equal to this, then times 100, equal to this. So this depends on your calculator, so you study how your calculator will be. 5.13%. Okay, because calculators are sometimes different. E exponent 1 gives us 2.718. Yeah, so it depends on your calculator. Okay, I explained this in the previous videos with the calculator on your computer machine, on your laptop PC. So view those videos, and I explained it there with that.